Hi, it's Miss G here. In this video, you're going to learn what molarity is and how to make a molar solution. Molarity is really just a way of describing the concentration of a solution. It's specifically moles of solute per liter of solution. So it's important that we review the terms solute and solution. The solute is the substance that's dissolved. So if you look in this picture here, I've got some sodium chloride being dissolved in water. So this would be the solute. And the solution is the combination of the solute and the solvent together. So this entire picture here is the solution. So again, molarity is concentration, how many moles of solute you have per liter of solution. Let's say you wanted to prepare a 1 molar solution of sodium chloride. That would mean that you would want to put 1 mole of sodium chloride per a liter of solution. So the first thing you would do is you'd weigh out 58.5 grams of sodium chloride. That's the molar mass of sodium chloride, or a mole of sodium chloride. And you'd put it into a volumetric flask. That volumetric flask would have to be a 1 liter flask. And then you'd add water, dissolve the salt, and then add enough water to the mark on the flask. Then in the flask, you'd have a mole, or 6.02 times 10 to the 23rd formula units of NaCl, and you'd have a total liter of solution. That would be a 1 molar solution. I really like this graphic from Flynn Scientific that shows you how to make a molar solution. You're going to mass out your solute. You're going to put it into a volumetric flask that's filled about a third with water. And then you're going to dissolve that solute. You can dissolve it by putting a stir bar in and making sure that you really fully dissolve that solute. And then you just add water to the mark. Sometimes I like to do this whole process right here in a beaker. Then I pour the dissolved solute and that resulting solution into a volumetric flask and then fill to the mark. You should be able to calculate how to make a molar solution if you need any particular volume and any particular concentration. So you can use dimensional analysis to do that, and this is a sort of a generic formula you can use to solve these types of problems. So you may want to write this in that space right above that Flynn diagram. You're going to take the volume of solution that you want to make, it has to be in liters, multiply by the molarity. Again, molarity has units of moles per liter, and we're going to multiply by the molar mass of whatever it is that you're dissolving, and that'll give you the mass of solid that you needed to dissolve. So let me show you how that looks for this particular question. This is at the bottom of your notes. Describe how to make 250 milliliters of a 0.400 molar potassium chloride solution. So the first thing we're going to do is write down our volume in liters. What I usually do is just move this decimal place over 3 times and automatically convert this to liters. The next thing I do is I'm going to write down this molarity, but I'm not going to write a capital M. Instead, I'm going to use the units moles per liter. Capital M really means the same thing as moles per liter. It's just kind of a shorthand, but I prefer to write moles per liter. So you can see when I write that out, the liters are going to cancel. I'm left with moles of KCl, and now I just need to convert that into grams, and so I'll look up the molar mass of KCl, and I'll multiply this by the molar mass. By doing so, that allows me to cancel moles. Now I'm at grams, and I'll just do the math to solve this. So I'll take 0.250 times 0.400 divided by a liter times 74.55 divided by 1, and that gives me my final answer. Here it is, 7.46 grams of potassium chloride. The beauty of this formula is you can insert any volume here, any molarity, and you'll end up, in any molar mass for whatever substance, and you'll figure out how many grams of that substance you have to dissolve in order to get your solution. So to review, molarity is moles of solute per liter of solution. We just did a problem where we took 7.46 grams of KCl, put it in a 250 milliliter volumetric flask, dissolved the solute, added water to the mark, and then we ended up with our 0.400 molar solution. And that's it.